This is a recording of a public forum held on rat lungworm disease in Hawaii caused by the parasite Angiostrongylus cantonensis. It was held at the University of Hawaii at Hilo College of Pharmacy, November 9, 2011. The moderator is Dr. Sue Jarvie, Associate Professor in the College of Pharmacy, University of Hawaii at Hilo. Dr. Rob Cowie, a snail taxonomist from the Pacific Biosciences Research Center at the University of Hawaii at Manoa, Dr. Rob Hollingsworth, an entomologist with the U.S. Department of Agriculture Pacific Basin Area Research Center, Jim Hollier, Director of Agricultural Development in the American Pacific Program in the College of Tropical Agriculture and Human Resources at the University of Hawaii at Manoa, Dr. John Martell, Associate Professor of Medicine at the University of Hawaii John A. Burns School of Medicine, and a physician at the Hilo Medical Center, Marlena Dixon with the Hawaii Department of Health, Dr. Ann Kopsa, Vice President and Invasive Species Coordinator from Malama Opuna, an environmental nonprofit organization, and Kay Howe, who is a community educator and whose son Graham was a victim of rat lungworm disease. This forum was sponsored by the University of Hawaii at Hilo College of Pharmacy, by the National Institute of Food and Agriculture of USDA, University of Hawaii at Manoa, and Global Hope. I would like to start off this forum by reminding everyone that rat lungworm disease is not unique to Hawaii. It is truly a global disease. The causative organism is a nematode, a worm called Angiostrongylus cantonensis, which was originally discovered in Canton, China in the 1930s. This worm reproduces in rats and completes further development in mollusks, like slugs and snails. Since the 1930s, rat lungworm has spread to at least 30 other countries, likely by rats on shipping vessels. Since the first case of human rat lungworm disease was reported in 1945, nearly 3,000 cases have been reported worldwide, with the highest numbers being reported from Thailand and China. Here in Hawaii, we have all the basic ingredients for outbreaks to occur: rats, slugs, snails, and the nematode. And rat lungworm disease has been reported in Hawaii and other Pacific islands since the 1960s.
Okay, well, while she's doing that, let me just preface what I'm going to talk about by saying that this workshop, this forum, and future fora that are going to take place on the other islands are funded in part by the grant from the United States Department of Agriculture that I and Jim and Rob and a couple of others who are not here were able to get to bring together a bunch of people from all over the world, all those countries that, or some of those countries that Sue just showed you, to all experts in their fields to discuss what is and what is not known about rat lungworm disease on a sort of global scale. And we brought together people who range from people like me, who I'm a snail person. That's what I work on, is snails. And so I come from that end of the spectrum here. We went through everything from epidemiologists, parasitologists, food safety experts, all the way through to people who developing diagnostic techniques for the disease, all the way through to physicians who actually treat the disease. And so we all got a really good sort of overview of the entire spectrum of what is and what is not known of the disease. And the idea, as Sue said, of this meeting is to distill what we came up with at that meeting in Honolulu back in August and provide it to the community to the extent that we can. So that's the purpose of this meeting, and that's partly how it's sort of come about. So, as a snail person, what I'm going to talk to you about is basically the biology of rat lungworm, so that you all understand how it actually works. Because it's very, very important to understand the mechanisms by which the worms get around in order to understand how to deal with the getting infected and so on. So this first slide, it's a little bit complicated, and I'm going to take a minute to go through it. quite carefully. I don't think there's a way of... I can point, if everyone can see it, I can point to this screen, but I can't point to the other one. So what happens is that we'll start here in this cycle. This is blocking the wording up here, but what this says is definitive host. The definitive host is the host in which the worm matures and reproduces. And that's, in this case, that's rats. So what happens is that rats defecate material that includes the first stage of the worms. Snails come along and eat the rat feces that contain those first stage worms. Sorry, wrong button. They're really close together. And then the worms mature to the so-called third stage in those snails and slugs. What happens then is that a rat comes along and eats the snail or slug and ingests those third stage worms. Then those worms, obviously they go down the mouth of the rat, down into its intestines ultimately. From its intestines, they penetrate the wall of the intestine, get into the blood system, circulatory system. Then they move from the circulatory system into the central nervous system, and we're getting closer to the brain here. And that's where they end up, maturing to the fifth stage. So they've gone from the first stage in rat feces, eaten by snails, reach the third stage in the snails, then a rat eats the snails, ingests the third stage larvae, which reach the central nervous system and mature to the fifth stage. Those fifth stage worms then move back into the bloodstream of the rat. There they mature and mate, and in fact in the heart and the pulmonary artery. And females lay their eggs there, and those eggs are just washed through the circulatory system from the pulmonary artery into the alveoli of the lungs. What happens then is that they hatch there into brand new first stage worms. And those worms work their way up the windpipe and get swallowed back down the gut of the rat, defecated out the back end, and the cycle starts again with snails eating first stage worms. So you've gone all the way through the cycle. And this is a natural cycle in the wild. This is how they've evolved to be. It's complicated and it's sort of horrible, but there it is. That's how it works. Now, this whole thing takes about 45 days. The only sort of real variable on that is this stage here. Because when the snail eats the first stage worms, the worms mature at the natural rate, but if the snail is not eaten by a rat, then the worms just stop there at the third stage until they get eaten by a rat, or until the snail dies. So this stage here can be longer or shorter, so you can add however long you like. You can add however long you like to this 45 days sort of minimum for the cycle to take place. That's in the rat. And this is what it looks like inside the rat's brain. And these worms, these are adult worms in a rat's brain. Here's one here. That's about maybe 1.25 inches long. Just think about that. Think about that. Okay, this is what happens. This is how we get infected. So the same thing happens. Rats defecate feces with first stage worms. The worms are the feces are eaten by snails and slugs. The worms mature to the third stage in the snails and slugs. But then, instead of a rat eating the snail or the slug, someone else eats the snail. So I didn't actually eat it. So I ate the snail and slug, and the same thing happens. The worms go down here, penetrate the wall of my intestine, get into my circulatory system, move from my circulatory system into my nervous system, ultimately into my brain, where they reach the fifth stage and mature to the fifth stage. But my brain is different from a rat's, thank God. And they can't find their way out. And so they die there. And that's dying there seems to be what causes the major symptoms of rat lungworm disease, which, as most of you probably heard, is also known as angiostrongylitis, and the symptoms are described as eosinophilic meningitis or eosinophilic meningoencephalitis. Okay, so that's the cycle. It's not a cycle because it's not complete in humans. Very similar to the rat, but it stops at the 5th stage in your brain, and that's what causes the problem. So, unfortunately, the thing is covering the first word there, but that word is parentenic. Don't need to worry about that. But there are other kinds of hosts, other than the definitive hosts, which are the rats, the intermediate hosts, which are the, and I should have mentioned before, intermediate hosts are the snails and slugs, and accidental hosts are things like us who eat them by mistake, and the cycle cannot go through. I keep doing the wrong thing. The parentenic hosts are other organisms that can get infected by eating rat feces, for instance, or by eating an infected snail or slug with worms at either 1st stage, 2nd stage, or 3rd stage. But the larvae, in that case, do not mature. They don't move from one stage to the next. They just stay put in these parentenic hosts, and that's that. But what can happen is that if something, you or I, for instance, eats one of these so-called parentenic hosts, we can get infected through eating these as well. So there's a whole bunch of things there, and I'll come back to that towards the end of my presentation in terms of sort of local context. Okay, so you've all heard that perhaps the most sort of worrying snail or slug is this so-called semi-slug, which is seems to be most heavily implicated in spread of the disease, particularly on this island. And Ron Hollingsworth is going to talk a little bit more about that, I think. But what we've done, one of my graduate students has done, in fact, has been to screen a whole bunch of other snails and slugs that we've collected here in Hawaii from across the state. We've sampled from, do that again, and it turns out that of the 16 on this slide, all but 3 of them, these 3 here, did carry rat lungworm. So it's not just the semi-slug, it's all sorts of snails and slugs. And the fact that these did not carry them doesn't mean that they cannot. It just means that we haven't managed to pick up a snail or slug that didn't at that time carry the rat lungworm. Because other studies have shown that at least this species can indeed carry rat lungworm. This one here, you might know, this is the apple snail that is the big taro pest in Hawaii. This one, yeah, it carries rat lungworm, so not a good idea to eat that. At least it's not good. I'll come back to that. So we've done this survey. We've covered all the islands quite extensively. We could probably do more intensive surveying in this area, for sure. We haven't got the money for that. But what we've shown is, these are really close together. What we've shown is that the red dots are where we've detected rat lungworm in snails and slugs. The yellow dots we did not detect. So rat lungworm is on all the islands except for Hawaii. Hawaii, you just see a red dot. Oahu, Molokai, Maui, Big Island. None found yet on the Lanai, but we've done very little surveying there. So that's not showing it doesn't exist. Okay, how do you get it? And what are the relative risks of the different pathways by which you can get it? Obviously, if you eat snails and slugs intentionally, raw snails and slugs, then you stand a really good chance of getting sick. And just as a little bit of additional information, the first case in Brazil, which was in 2007, was two guys got drunk and they saw a big slug crawling around. One said to the other, "I dare you to eat it." And I said, "No, I'll only eat it if you'll eat it." So they cut it in half. They both ate it, and they both got really sick. And there's also been a recent case in Hawaii, just last year, I think. There was actually a guy in the military. He was up in, I think, Schofield, up in the mountains somewhere, camping overnight with his mates. And they saw this big giant African snail, and the one guy said to this guy, said, "I dare you to eat it." I said, "How much?" $200. And so he said, "Oh, all right, I'll eat it." And so a few days later, maybe a week later, he felt this really bad headache, and he wasn't feeling at all. He went into Tripler, and the doctor there happened to know about this disease. A lot of doctors don't, as we know. He did happen to know, and he thought, he asked the guy, "You've been hanging around with snails? You've been messing around with snails?" And the guy said, No. And then, so he treated him as if he did have rat lungworm disease. Sent him away, he came back even worse. And the doctor began to sort of build a rapport with this guy. And eventually the guy said, "You sure you never played around or touched or with snails?" He said, "Well, actually, we did play around with some snails the other day up in the mountains." Eventually, the guy admitted, "Yeah, I ate one." I mean, he ate it raw, and he got really sick. The doctor says, "Well, okay, did you claim the bet?" He said, "Yeah, I got the $200. Was it worth it? Hell no." So anyway, that's just a little anecdote. So the point is, this is an apple snail. I work on apple snails as well, that's how it happened in the lab. Undercooked or raw apple snails are actually a delicacy in Hawaii. I know that some people eat them, in Thailand. I know that some people eat apple snails in Hawaii, although I think mostly they get them cooked. But it's important that even though you cook them, that you cook them thoroughly. So, that's eating raw snails deliberately. You can eat raw snails accidentally through the sort of debris associated with preparing them for cooking. This is a picture of us in Brazil a few years ago. We were eating apple snails here. But this lady who cooked these snails prepared them out in the Amazon forest on this wooden board. And you can see there's all sorts of junk here, probably bits of snail. And you can imagine if she got those on her fingers, licked her fingers or whatever, it's a problem. So you have to be careful in this kind of situation. If you're preparing snails, and maybe some of you do eat snails, if you're preparing them, make sure that you thoroughly wash your hands of any uncooked debris from the preparation of the snails. This is the mechanism by which most people feel that people are getting infected here in Hawaii. And this is through eating snails or slugs unintentionally associated with vegetables or other produce. So the snails are uncooked, you don't realize you're eating them. These things can be really, really tiny. So, for instance, the semi-slug that Rob's going to talk about, a baby one of those may only be a newly hatched one, for instance, may only be about 1/4 of an inch at most long. And a snail or slug that size can still carry thousands of worms. These worms are minute at the first stage. So it's very important to make sure that you do not have even these tiny, tiny baby snails and slugs in your produce. So washing them carefully is the key to that. Some people have suggested that you can get infected through eating slime. People have demonstrated that snails do shed worms in their slime trails. So even if you wash the snail off the produce, there still may be a bit of slime trail left on a lettuce leaf, for instance. No one's actually demonstrated, although of course it's very hard to do this, no one's demonstrated that this has ever been a pathway via which someone's got infected. But, and it's also the case, though, that the people who have looked at the slime have shown that, okay, there are worms in the slime, but very, very low numbers compared to the actual snails themselves. So the chances of getting infected by eating slime, maybe not negligible, but very slim by comparison with eating an actual raw snail. Okay, just handling snails and slugs. Again, the slime is an issue, but maybe this is a little bit more of an issue than just having a slime trail on your lettuce leaf. A lot of this is children playing with things in the dirt and then sticking their hands in their mouth. There's a lot of school projects work with snails. I went to a school a few years ago where they had a tank full of African snails that they were breeding and using as teaching vehicles. So that's an issue, but perhaps not as important as actually eating the snail. This is not a good idea. The world record for the number of snails on your face. Okay, I knew that would be enough to put it in. But it's not a good idea, obviously. Some people have suggested that contaminated drinking water could be a source of infection. Okay, there's two things that come up here. If a rat, and we only just talked about this evening prior to the meeting, and I wasn't going to talk about all of this, but it says if a rat gets into your drinking water, the rats only have rat feces get into your drinking water. Those will only have first stage larvae. If we drink the water with first stage larvae, those larvae are not going to be able to infect us, because we have to be infected by the third stage. That's the third stage that we get by eating snails. Snails eat the feces with the first stage, and the first stage matures to the third stage of the snail. So that's not an issue, as far as I can tell. A more likely issue is that if snails and slugs contaminate the drinking water, die in the drinking water, release the worms into the drinking water, that's possibly a mechanism by which you could get infected. However, one snail in a tank this size is going to have such a huge dilution effect in terms of the numbers of worms that you actually ingest, that probably this is a not very important mechanism for getting seriously infected. I say probably, I say maybe, because really we don't know enough about all these things to be able to say definitively what the answers are. Remember I talked about so-called parotenic hosts. These are these other things that eat snails and slugs and then get infected by, and then get the worms from eating the snails and slugs. But the worms do not mature in these organisms. In various places in the Pacific, land crabs, shrimp, prawns, so on, have been detected as carrying the worms. And these are things that people eat. Similarly, here, these things are called flatworms. There's no sort of, I'm not sure how to describe them in terms of sort of lay language, but they're a special kind of worm. We do have them here in Hawaii, and some of these prey on snails. So it's probably not a good idea to eat these. And again, these can probably be found in or on your produce, perhaps in a bunch of lettuce. So it's important that you make sure that there's none of these kinds of worms in the produce. Now, no one's actually tested this in Hawaii. No one's actually looked at any of these parotenic hosts to find out whether they really do carry worms or not. So that's something we don't know. The assumption is that they can. Some people have suggested that we can become infected through an open wound. Theoretically, this is possible. No one's ever shown a case where this has happened. And so my guess is that probably it's a very unlikely pathway of becoming infected. But again, we don't really know enough. So the upshot of all this is that we think that the severity of the disease, the severity of the symptoms, is related to the dosage of worms that you ingest. What we don't know is how many worms it takes to cause, in your brain, to cause really serious symptoms. Neither do we know how many worms you need to ingest in order that some get to your brain. Is it ingest 10,000 worms for one to get to your brain, or is it ingest 10,000 worms and 9,999 get to your brain? We do not know that. And so it's knowledge about the dosage rate is very, very poor, and the whole thing is not well understood. So, to sum all that up, basically the most sure way of getting infected is by eating a raw snail or slug. So, that's the greatest risk. So, the key is to thoroughly cook it. Thoroughly cooking the snail or slug will kill the worms and result in no possibility of infection. If you only cook it partially, then you've got a problem. So really thorough cooking of snails is important. Obviously, if you accidentally eat an infected snail or slug, the chances of getting infected are, again, just as serious. So those two are clearly the most important mechanisms by which you become infected. These other mechanisms, the slime, the drinking water, open wounds, maybe not so much. And I put a slide in there for questions, but as Sue said, we're going to have questions at the end. However, this website, which I can give to anyone, maybe Sue can give it to people afterwards, is the website of the workshop that took place in August in Honolulu, and it has PDFs of all the 30 or so presentations, ranging from my own presentations, of which this is a summary, all the way through to the presentations by Rob, Jim, Marlena, Kay, and everyone else, including the physicians who treated the disease, and patients, and so on. There's about 30 presentations, and it's available. It's a huge resource of information. And on that note, I will finish.
Thank you, Sue. And I want to thank the Global Hope people, too, who gave us the publicity for this meeting so we could get the word out. They really did a great job. So I'm going to be talking about control and management of slugs and snails, which carry the rat lungworm disease. And I'll mention a few of the species that we have here in Hawaii, which are high risk. The African snail, the giant African snail, is invasive species that is well known around the world. It's in the tropics, and it is an important carrier of rat lungworm disease. And I think most of you are familiar with this species because it's quite common, especially this year. We also have the Cuban slug, which got to Hawaii much later than the giant African snail. In the case of the Cuban slug, it's probably around 1980 that it got here. And it's very common around people's houses and in garden situations. It's also a very good carrier of rat lungworm disease. These Veronicella slugs can have a couple of thousand nematodes or more in their body. And their external morphology varies quite a bit. You might have noticed this slug around Hilo. Sometimes it has 2 black stripes, sometimes it has none. In rare cases, it can even be an albino-looking slug, so it varies quite a bit. And then there's this one that we've heard a lot about, maybe read a few newspaper articles about, called the Asian semi-slug. It was first found on Oahu in 1996, documented on this island in 2004. It feeds on a lot of different things, like most slugs and snails. It's a general feeder. Papaya, hibiscus, lettuce, dead plant matter. It's very abundant around human dwellings. In some cases, it looked like it's sort of taking the place of the Cuban slugs. And it's believed, actually it's known to be a very important carrier of rat lungworm disease. Here at the bottom left, you can see, for comparison, the Cuban slug, and on the bottom right, That's a species of Doroceros, which looks a little bit like the Cuban, it looks a little bit like the Asian semi-slug, but because it has a hump. But it doesn't have this piece of shell on its back, and the hump is not nearly as large. The Asian semi-slug also has this keeled tail, which is kind of distinctive for identification purposes. So back in 2005, we carried out a survey for this species. We put an advertisement in the local newspaper with a picture, and we asked people to call us. And we got a lot of phone calls, mostly from the Puna area. We found that positive finds when we went to these properties where people said they thought they had the semi-slug. All of these properties where the circle is gray were positive. In fact, there was only one place in Puna we went to where it was negative. That's indicated by a circle that's white. And we had a negative finding there up near Hamakua, close to Honoka'a. And then we even had a positive find over there in Kailua Kona, because the people there had a second home, Paradise Park, and they had accidentally buried it there. So this is just an inset showing the Paradise Park region where a lot of our positive finds were located. So when we found these slugs, we interviewed people about their experiences with this semi-slug. And we collected all the Cuban slugs we could find and all the semi-slugs, and we sent them off for the Centers for Disease Control in Atlanta, Georgia, and they assayed them to see if they were carrying the parasite. And it turned out that the semi-slugs were extremely heavily infected most of the time, and in comparison to the Cuban slugs, a higher percentage of the semi-slugs were infested. So it was up to 86% in the case of the semi-slug. The percent of Cuban slugs of the large specimens that were infected was like 35%. But here's what's kind of interesting is that with the semi-slugs, even some of the small ones were infected. And that was not the case with the Cuban slugs in our sample. So here's a real problem, as Rob alluded to, is that you have the eggs of the semi-slug and then the neonates, which were quite small, like 1 millimeter or 2 millimeters, and they can end up in lettuce, for example, and not be observed unless someone really has good eyes and is being careful. When we did our survey, we asked people questions about where they saw the semi-slugs, and we also made our own observations. And we found out that these semi-slugs love to hang out on plastic and plastic-like materials, a little bit more so than other species of slugs and snails. We commonly found them in food preparation areas, barbecue grills, outdoor sinks. We found them on the walls of homes, and people reported that to us. And we found them on catchment tanks, and even inside the tank on the black saran. And in some cases, they fall in the water, drown, and the nematodes in their bodies would be released into the water. It could pose a risk, as Rob mentioned, although the dilution factor should minimize that compared to, say, the risk on lettuce. So in terms of life history observations, we found that this species is frequently associated with palm leaves. Populations are peaking in the winter time, and then the adults will lay their eggs as a cluster, not on the soil, but in like on a piece of plastic or some clean area, and then the adults will die in the immediate vicinity very commonly. So thinking about the life history, we wondered if it might increase the risk of people getting this rat lungworm disease. In Okinawa, Japanese scientists conducted a study, and they found that both the Asian semi-slug and this flatworm species, Platydemus, were important carriers of rat lungworm there. And we have both of those species here. But here in Hawaii, because we know that the adult semi-slugs die in the vicinity where they lay their eggs, that poses another risk, because the the nematodes would exit the bodies of the dead adults, and they could be picked up by the newly hatched semi-slugs, or they could be picked up by this flatworm species, which is a predator of slugs and snails. Now, Rob said that we didn't have any data yet as to whether or not these were carrying the nematodes. But Rob, we do have a little bit of data, and I think there's just 2 samples. And one of them tested out medium, basically for nematodes, medium hot, meaning it had a fair number of nematodes, and the other one tested high. So just as it is in Okinawa, we think that this is a risk factor for us here. Now, I just want to shift gears here a minute and talk about control of slugs and snails, because you can stop the risk of the disease 2 ways. You can either control the slugs, or you can control the rats. And if you do either one of them 100% over a large area, you could stop the disease in its tracks, because the parasite has to, be in contact with both in order to complete its life cycle. So gastropods, which include slugs and snails, are nocturnal feeders, and many times the damage that they cause is attributed to insects. So while the damage may look similar to insects, their poop looks a lot different. This is the feces of a slug and snail. That's typically what it looks like. Whereas with caterpillars and most other insects, it's going to be more like a pellet. So when I look at my lettuce at home, if I see poop like, oops, let me go back. If I see something that looks like that inside the lettuce, personally, I'm going to throw out the whole thing. Because even though I could wash it, I just prefer not to deal with that risk. But if I see caterpillar poop, I happen to be an entomologist, I'm pretty good at recognizing caterpillar poop. No problem. I might wash it anyway, but I'm not going to throw it out. So in the tropics, these slugs and snails present a rat lungworm risk both for home gardeners as well as for commercial growers. And even homeowners and their pets are at risk. But the recommended control measures are pretty much the same in all these cases, and they include poison baits, the trapping, and habitat manipulation. So these are some of the common baits that people use for slugs and snails. This one here on the far left is iron phosphate bait called Sluggo, which is safe for animals. The other 3 have metaldehyde as the active ingredient, and so that's going to cause a risk for pets. So use metaldehyde bait products if you're trying to save money and you don't have any problems with pets, maybe eating the bait. Whenever a slug or snail contacts metaldehyde, it will immobilize the slug or snail, and it'll just dry up there and produce a lot of slime and dry up, and it's going to look like this. But the 1% iron phosphate bait, like Sluggo, is a naturally occurring active ingredient. It's naturally occurring in the soil. The slug or snail, after eating it, will immediately stop feeding on their garden, and eventually they will die. But the main advantage is it's safer for domesticated animals. The disadvantage is it costs more, in some cases, efficacy is less. If you look on the internet for natural control methods for slugs and snails, you'll see a lot of different things that are recommended. Some of them work, some of them don't. Like, for example, I've tested diatomaceous earth, and in my test with snails, it didn't work at all. But watering less often is good advice. Copper bands do repel to some degree. Some snails and slugs will run the gauntlet. Beer traps are frequently recommended, and that's the one that gets the most internet interest, I think. Beer traps. Maybe it's because people are just so interested in beer themselves. A lot of people complain that they don't want to waste the beer. And so I think that this kind of trap is for really those people who either have some beer that was given to them that they don't like, or maybe they just, they're really dedicated to their gardens. But it is a lot of work, and it takes a lot of traps, and you have to keep servicing the traps very frequently to make that work. So I think some of the most useful methods for controlling slugs and snails are these: to limit the number of moist hiding places and breeding places. For example, remove rocks, concrete blocks, boards, things that they hide under. Or, alternatively, do just the opposite. Put those things out there in your garden, but check them every day. Turn them over, get the slugs and snails, pick them up with a gloved hand, not your bare hand, and put them in soapy water to kill them. And eliminate them that way. That's a very good technique. And just make the environment drier if you can do that without hurting your production of your garden. Improve the drainage and remove food sources. Slugs and snails like to eat like dried up leaves. They like to eat leftover vegetable matter, so that works as well. And with that, I'll turn it over to the next speaker.
So, you guys have scared me. Thank you very much. One of the things that Rob didn't mention out of this conference that we had in August was there were way more questions than answers. I mean, in fact, we probably have 100 things that we don't know about. So at the end of the night, you're going to ask questions of us, and we're just going to simply not know. The reality is this is an emerging disease, and as a result of that, not a lot of money's been spent on it. A lot of people haven't been able to concentrate on it. So we tell you right now, we hate to disappoint you, but we may not have answers for everything. It's just one of those things as this evolves. A lot of what both the gentlemen have talked about and Marlene will talk about is in this publication I have right here in my hand. And if you want one of these at the end of the night, you can have one. If you can only just take one as opposed to a handful, that'd be great, because these are in a limited supply. But this is pretty much our current information on rat lungworm, and also some of the things that Rob talked about, Rob too, and I'll talk about right now. So I'm going to talk about the commercial aspect of this. I'm a food safety coach. It's a person who goes on people's farms and helps them understand where their risk factors are. And typically, it's things like poopy hands or fertilizers or pesticides not used correctly. But in our case, we have the rat lungworm. So we're going to talk a little bit about that. I want to disclaim something, though. One of the things about our advice is if you take it, you take it and you use it at your own risk. So I just want to make sure that the information that we're giving here, that you realize you're taking it that way. Okay, so I'm going to talk about how to reduce the chance of getting rat lungworm. We use the word nematode. A lot of people recognize nematodes as a soil animal, but it's also, in the case of rat lungworm, it's also considered a nematode. So you hear us say the word worm or the word nematode, it's the same animal. I'm also going to talk about post-harvest handling. After you harvest something, how can you keep as safe as possible? And then something about a new project we're working on, Rob Cowie and I and a few other people, on some water sanitizers. After you harvest the crop, what could you put in water to dispatch the little buggers? And I first want to start with a little bit about good agricultural practices. This is something that's so important in the news recently. If you have been following the cantaloupe situation out of Colorado, where 29 people have now died from it, this is in a lot of people's minds as getting our food system safer and safer. So good agricultural practices were started in 1998 by the Food and Drug Administration. They are a set of guidelines that indicate these are the best practices when it comes to reducing microbial risk, and it also has pest and pesticide reduction practices as well. So when we do food safety coaching, we'll come out to farms as an example, and we'll look at your land. Make sure the land wasn't used for something before you started growing a crop. That could be a problem. Or make sure that your surrounding land, if you were at a lettuce patch right here, and you have a very steep hill and there's cows sitting right next to it on the other side of the fence, that can be a problem when it rains. Worker and human hygiene, very, very important. It's absolutely amazing how many farms I'm on where people don't understand that you should probably wash your hands before you harvest the crop. And people say to me, but I'll get my hands dirty. Well, that's great. Soil probably isn't a problem for you, but what you brought from the bathroom on your hands is a problem. So we teach people all about that sanitation. Water usage, both for irrigation and produce wash water. Very, very important. What are you irrigating your crop with? Especially the edible portion of the crop. If you're growing something like a banana, you can put just about any water you want in it because you put it on the ground. But if you're growing something like lettuce, you have to really consider, well, I'm watering this from the top. What's in that water? Pesticide use, this is very important. This is something that just was triggered 2 weeks ago in Honolulu, or maybe it was last week. A farm was using a chemical they shouldn't have been using, and they got caught. And so pesticide use, you have to use pesticides the way they're labeled. And both conventional farms and organic farms can use pesticides, but they're on a very specific allowed list. And then pest control, that's what we're going to talk a little bit more about. And this includes managing rats, slugs, and snails. And then animals themselves. Dogs, cats, cows, pigs, sheep, whatever it is, around produce is a risk factor. Even if you grew up as a kid on a farm where you had sheep running around your lettuce, we don't do that today. And then post-harvest handling, how we handle it after it's been harvested. It's very, very important not to contaminate it. It was absolutely fine in the field, hanging there as a tomato on the vine, and then you brought it in your packing shed and did something to it that actually contaminated it. So I'm going to talk about pest control. Rob Hollingsworth pretty much stole some of my power here, but the main thing is to keep your farms and gardens clean. And this, I took the picture yesterday, actually, of somebody's farm. And this is a perfect breeding area and housing complex for rats, slugs, and snails. And they just hang there at night. They go out and they eat things. And so more and more and more when we go out to farms, and this is the painful part of going to people's farms, is they don't want to clean this up. Or you don't want to clean it up. But this is where rats and slugs and snails hang out. We need to have farms and gardens that have areas that are cleaner than this. And that's, of course, not everybody. Don't say everybody looks like this. It's not true. But if you have this type of situation, it really needs to be cleaned up if you want to reduce the risk. Trap and kill. This is the bottom line. Rob mentioned commercial trap systems for rats along with slugs and snail control. Now, in June of this year, the EPA changed the laws on using baits when it comes to rats. Before, you could go to the hardware store and get a bucket of bait, peanut butter bait, and put it out for rats. You no longer can do that because kids and animals were hurt by this. And now EPA requires, if you're going to use that type of trap, that it's a sealed trap, one-time use only trap. There's no more, I'm going to buy this bait and just put it out. Now, some of this still may be available in hardware stores, but going forward, supposedly none of this stuff is supposed to be available unless you're a pesticide applicator. Second thing is collect the slugs and snails when you're wearing gloves and tongs. Very important. Rob Cowie mentioned this stuff. You know, it may not go through your skin, but if you touch your mouth, especially if you're with children, children are always putting their hands in their mouth. You want to pick them up with tongs and gloves, put them in a plastic bag, put them in the trash, or put them in soapy water, and then wash your hands a lot. Okay, so we don't want to be touching our faces after we went out and did a slug harvest. Now, a lot of farms, not a lot, well, a number of farms will have ducks on them, and you'll say, well, this is a perfect example of how I can just use nature to clean up slugs and snails. And that makes a lot of sense on the front end of the duck. But ducks have two sides, the happy end and the trumpet end. So in one way, we might be saying, this is great, we got a duck here cleaning up our slugs and snails. But on the other end, we might be actually applying salmonella onto a crop. So think about this very carefully. If you're using ducks on your farm or chickens or things of that nature, it sounds good, it may not be the best thing. Okay, harvest carefully. This is very, very important, especially in the areas where it's really wet here, because the slugs and snails can get wedged down into something like, taller lettuces that can go down there and hang out. And you saw Rob Hollingsworth almost clear baby slugs. You can barely see them. And when you're harvesting a whole lot and you're taking it down to the farmer's market or taking it to give to your friends, you're not paying attention, and you need to watch what you harvest. Don't harvest produce with damaged slime, slugs, or snails on them. Oh, we'll just wash it off later. No, don't harvest it. Harvest the good things, leave the things that have the damage, rogue them out later, or rogue them out first, wash your hands and go back in. But don't be mixing them and saying, oh, I'll wash them off later. Absolutely do not do that. And then don't assume that you can wash off the slime, or for that matter, any of the pathogens that are on there. Now, this is something that's only been discovered in the last couple of years, is this thing called a biofilm. So salmonella can put a little covering over itself, and you can wash it with chlorine all you want to, and it still will be stable until somebody bites it and eats it. So be very, very careful about, oh, I'll just wash this stuff off. Oh, yeah, the chicken just pooed on the lettuce or whatever it is, and I'll just wash it off. No, don't harvest it. Don't even think you're going to wash it off, because you may not. When you are harvesting, and especially if it's for your home garden, obviously if you tear it apart and you try to sell it at a store, it's kind of rough. But pull some of this apart and take a look at some of this if you have slugs and snails in your garden, to make sure that they're not hiding. And obviously use potable water. People who, and Trish McCumber's back here, she's my colleague, she's the water woman. If you ever want to learn about water tanks, the young lady back there has got it. You need to wash produce off in potable water. Washing it off in tank water, sometimes some of this tank water isn't all that clean. Whether it's got rat lungworm is almost irrelevant. It could have other things in the water. So be very, very careful when you're rinsing off your product. Hopefully it's done in potable water. And then lastly, using a water sanitizer. There's a number of products on the market that could be used. But in the case of a commercial farm, there's actually a relative small list of these products. And they have to match the label to the product. For example, there are chemicals, sanitizers out there that have a list of maybe 15 products on it. But papaya is not on that list. Really, you're not supposed to use it, because using it would be breaking the law. So it's a really kind of a tough situation. And to say, well, I'll wash it off in a sanitizer, don't worry about it, it's not going to give you 100% protection. So again, don't harvest it to start with. All right, finishing up here. Our research project going forward, we just got some money, and we will be looking at commercially available EPA and FDA registered water sanitizing chemicals. And we're looking at whether or not they can kill the slugs and snails and the rat lungworm nematode. We don't know. Nobody's ever had this problem before, and nobody's ever taken a bunch of slugs and snails. We'll be looking at about 15 chemicals times 15 host species. So we're rounding up the slugs and snails right now, shopping for the chemicals, and then we're going to be running a bunch of tests to see which one of them can kill the slugs and snails, and then we'll make that information available. Now, why can't we recommend something like beer to trap, or lime juice or salt water as a produce rinse to kill the pests? If you ever look at a can of beer, does it ever say this can be used as a pesticide? No. So I'm just kind of covering myself here. We don't know if salt can be used. We don't know if lime juice can be used, because if you get a lime, there's no pesticide labeled on the lime. Okay, so I can't recommend things that are without a label. So in our business, the label is the law. That's the way it goes, and we need to follow the law. And that's it for me. Thank you. So again,
good evening. I want to start with an editorial comment, which is whenever I start to talk about rat lungworm disease, I immediately get people's attention. And I think that has to do with this right here. If you were to purposely design a disease that touches all our fundamental fears and ick factors, okay, you couldn't come up with something more repulsive than rat lungworm disease. It's got rats. Okay, it's got worms. It's got slugs.
What's wrong with slugs?
Some people like slugs. I can understand that. But in a very primordial way, most of us find them yucky. So you've already had the background. It's a primary disease of rats, secondary disease of snails. you've seen the life cycle, you've learned, okay, that this disease is for the most part an accident, barring the few people who have a few beers and get into the dare situations. We aren't intended to be in this picture. There's the life cycle you've already seen now. I won't go over that. But if you accidentally get in the way, okay, you eat contaminated produce, you have a tequila and a slug, or this happens, then what happens next? Okay? You ingest the larvae, they go into your intestinal tract, okay, where they have to get into your body, and the way they do this is by burrowing through the walls of your intestines. Okay? Once they get through into the bloodstream, they migrate to your nervous system, and we'll talk about this a little bit. There's mechanical damage done, okay, as the worms travel through your nervous system. Because we are not the intended host, eventually the worms die in your brain, in the nervous system. And then there's a second set of damage that happens with the dying worms. The body is fighting back using specialized cells called eosinophils. Okay. Don't worry about the name particularly. I just want to cover what an eosinophil is and what it does. An eosinophil is a specialized white blood cell, and most of us know that white blood cells are the disease-fighting component of our blood system. On stains, specialized stains on blood smears, these cells stain pink to red, okay? And these cells are specialized in fighting parasites, okay, multicellular organisms, and they're also involved in moderating allergies and allergic responses. When you get an angiostrongylus infection, your body mobilizes these cells to fight back. And when it does, these show up in the spinal fluid and in the blood, okay? And it is one of our best markers that there is an invasion going on. It's not a direct marker, it's what we call a proxy marker, okay? These cells, we know there's something going on, then we raise the question, is this angiostrongylus? So, the first phase, after the ingestion, there is an invasion of the intestines, often accompanied by abdominal pain, nausea, and diarrhea. There's nothing special about these symptoms. Okay? These could be a viral infection. These symptoms are very similar, okay, to food poisoning. You don't know at this point usually what's going on. And
I didn't have any of those.
other people do. Okay? So it varies. Non-specific is often missed.
So there's no proxy markers at that point?
Eosinophils usually don't go up until they have gone through the intestinal wall into the bloodstream and the body recognizes it. Then, okay, they migrate, as we talked about, to the nervous system, okay, the brain, okay, and the body fights back. This is where you see the most common manifestations. Eosinophilic meningitis, remember we talked about the eosinophils are those special cells, usually shows up as a persistent severe headache. There's often migrating nerve pain, sensory disturbance, okay, feelings of tingling, of burning, sometimes even of hot and cold reversal, where things that should be cold feel hot and vice versa. Often there's urinary difficulty, And then you get to the scary part, because in the severe cases, you get an ascending paralysis, progressive weakness, coma, and in severe cases, death. Okay. Let's see, I'm not sure I can show this one, so I'm going to skip over. It's scary stuff. Okay. So how is the diagnosis made? Okay. The diagnosis currently is made indirectly. Okay. That we do not have easily available direct blood tests or spinal fluid tests that can tell us in a short period of time that this is what we're dealing with. So if you were to present to the emergency room with a severe headache, okay, this is what you would expect. You would get a history and exam, blood work, which may or may not show eosinophils on it, a CAT scan or an MRI, and a spinal tap. Everybody is familiar with what a spinal tap is. They insert a needle in the low part of your back and withdraw fluid for analysis. Okay. Only by putting all these pieces together can a clinician come to the conclusion that this is what we're dealing with. Okay? And you look at, is the history compatible? Was there a potential exposure? Are the symptoms compatible? Are the physical findings consistent? Do you find these specialized blood cells in the peripheral blood smear, the usual blood counts, and do you find them in the spinal fluid? It is rare to find the actual worms in the spinal fluid. Okay? It happens maybe 1 in 10 to 20 cases. We did have a pediatric case recently where the worms were actually present. I personally have not seen it on any of my cases. The first CAT scan and the first MRIs are usually perfectly normal. Okay? And specialized blood tests are usually done only by a few very specialized labs. You have to send these specimens off to the mainland, and by the time the results come back, the patient is either already better or very sick. So
what kind of blood test is that called?
It's called an ELISA test, an enzyme-linked immunosorbent assay, but you have to go looking for the labs. I know that other labs are in the process of development.
And I'm sorry, where are you from?
I'm from here.
I mean, are you the Department of Health? Are you just a doctor? Or I didn't catch what you represented.
Okay.
Which faction?
I'm University of Hawaii School of Medicine.
Oh, okay. Thank you.
Okay,
Sorry.
and the hospitalist program here at Hilo Medical Center.
Thank you.
Okay.
Ma'am, would you hold other questions till the end with everyone else, please?
Maybe.
That, as you recall, the worms really don't thrive in people. We're an accident. They can't complete their life cycle. What that means is this disease is a self-limited illness. Okay? The worms will eventually die, and the symptoms will improve. However, okay, a lot of damage can be done while you're waiting for this self-limited disease to run its case. Keep in mind, okay, that we really have no clear, convincing studies to show an effective treatment. The reason for this is that every case of eosinophilic meningitis is different, unique, runs a different course, and they're relatively uncommon. So putting together good, solid scientific studies to look at different treatment courses is extremely difficult. However, there are empiric treatments. That's treatments that you use based on your best clinical judgment, based on the presumed mechanism of damage that's being done during this illness. For example, remember we said the damage is done as the worms migrate, travel through the central nervous system. So if you can reduce the time of infestation, theoretically, okay, you can reduce that initial phase of damage. So there are anti-worm medicines, albendazole, mebendazole, and ivermectin, that potentially can reduce this time of infestation. The second part of the disease comes from the inflammation, okay? As your body breaks down, eliminates, and gets rid of those worms, okay? In that time, there's intense inflammation as the eosinophils attack the worms, the immune system kicks in, and there's collateral damage to the nervous system. Anti-inflammatory steroids, such as prednisone, okay, have been shown to reduce the duration of symptoms, that is, the length of headache. Whether they actually improve the long-term outcome, I think is yet unclear. There's always a trade-off. Any treatment has its potential for side effects. For the anti-worm medicines, okay, side effects are usually limited. They're usually minor, okay, that they consist often of gastrointestinal symptoms or mild neurologic symptoms. Okay? In this case, I'm not even sure that you would see this because the patient is already, okay, in neurologic extremis. So I have used these anti-worm medicines multiple times, have never seen serious side effects such as low blood count, bone marrow toxicity, seizure. Okay? They're generally safe. Steroids, anti-inflammatory steroids, okay, common side effects, increased appetite, weight gain, fluid retention, mood changes, insomnia, nervousness, okay. Short-term serious problems are susceptibility to infections, elevated blood sugars, diabetes, and some people, frankly, go nuts on high doses of steroids. Okay? The bad news is recovery is often incomplete, and the symptoms from the neurologic damage can last for years. So the question comes up, okay, so that's the treatment, okay? What can you do if you have reason to believe that you have accidentally eaten a snail or contaminated materials, or the next morning after your dare, you go into the emergency room and say, I just ate a slug. What do I do? We don't know, but using mouse models for primary prevention, giving medication, anti-worm medication, after the exposure has not shown to reduce the chance of getting infested. So you're better off avoiding exposure. It's already been covered. I won't go into any detail. And I will make myself available for questions, okay, at the end of the program.
Good evening. I'm Marlena Dixon with the Department of Health Disease Investigation Branch. We've learned a little bit tonight about rat lungworm disease, and I'm going to talk a little bit about the history of the disease in Hawaii and how we collect data and statistics for it. I'll present some statistics for our state and our island specifically, and then I'm going to conclude with some frequently asked questions that we get in the department all the time, and hopefully kind of answer some of your questions before you ask them. So a very brief background. A review of the literature actually shows cases as early as 1958 back in Oahu. The Department of Health didn't actually start looking at data and tracking until 2005. And in 2007, we began active surveillance, so tracking cases as they come along. Here's a little chart kind of showing you the numbers that we've had from 2007. And as you see, they're relatively low. So looking at numbers like 2 for 2007. 2010 probably saw the most at 9. The interesting thing to note here, though, is that about 90% of these cases took place on our island, on the east side of Hawaii. And this is state data. A research article was put together by the Department of Health, which is available there at this website. Cases of eosinophilic meningitis from 2001 to 2005 were reviewed. Because we weren't tracking at that time, we weren't sure how many of these cases were actually due to angiostrongylolitis or rat lungworm disease. So it was reviewed, and we got our data from 2001 to 2005 from this article. And the other interesting point to note here is this top line is the island of Hawaii, right here. We noticed a spike here in 2004, and what was interesting is, I believe Rob mentioned, that was when we first saw the semi-slug here on the Big Island. Right here we saw the spike. This photo was taken actually on one of our slug catching expeditions with Rob. This is an example of how small the semi-slugs can be. This is a baby semi-slug on a nickel. That's the actual size there. So as you can see from the size, it's very easy for something like this to be hiding in your produce, very at the bottom, where you can easily miss it if you're not washing it carefully or looking with glasses on in my case. So after doing this, it kind of led us to kind of discuss, why are we seeing cases here on the Big Island and not other cases? Not other islands, excuse me. As we saw, the parasite exists statewide. So why are we seeing it here? Talk a little bit more about that later. I'm going to move into how we document cases. We classify cases into 2 areas, probable and confirmed. Confirmed cases basically only require visualization of the larvae in the cerebrospinal fluid. It's very rare that we actually see that. In about 30 to 35 cases, I would say maybe 2, we've actually been able to visualize larvae and confirm them. Most of our cases fall under probable. I'm not going to go into details, but basically we have to pair up several different factors to determine whether or not this is actually a case of rat lungworm disease. So first we take a look at the clinical signs and make sure that they're compatible. We rely on the physicians for that. The Department of Health, we're not physicians, so we rely on people like Dr. Martel to tell us what their clinical signs are and if they're a match. If the patient also has eosinophilic meningitis, then what we look for is 10% or higher in cerebrospinal fluid. That triggers a phone call from the lab at the hospital and an investigation on our part. Because there's no actual diagnostic tool, this is a diagnosis of exclusion. So physicians actually are tasked with kind of eliminating all the other possibilities before deciding, yes, this is possibly a case of rat lungworm disease. We have a third gray area called suspect cases. These are people who have the symptoms, classic symptoms. They look like they're actually a case. However, no diagnostics have been done. No lumbar puncture, no blood test, nothing diagnostic. So we follow them, we track them in case they pop up later, but they're not actually included in our data. So that's kind of why a lot of our numbers are low. Not everybody wants to go to the ER and get a spinal tap. So a lot of our less severe cases are going to fall under suspect, which is why our numbers are so low. Kind of ran through that really quickly. The presenters ahead of me kind of covered most of my information. Thank you very much. So I am the field investigator for the Department of Health here on the east side. So I am privileged with getting all the phone calls and all the questions. So what I did was I kind of compiled the questions I get most often, and here they are. I get number one almost all the time. Can I send slugs to you from my garden to you for testing? And I get care packages all the time, which I appreciate. I love getting gifts. However, slugs and snails, yeah, our front desk doesn't appreciate that very much. And the answer is no. Because what would it tell you if you sent me a slug and I tested and it was negative? Is that going to tell you that the rest of your garden is now safe? Not really. So we know that a large majority of mollusks in our state are infected. So sending me from your garden is not really going to tell you any much more than that. It's also intensive on our end. We have to mail it off to CDC for that to Atlanta. We can't test it here in the state, so it's also very costly. Excuse me. Second question I get a lot is, what do I do if I find a slug in my food at a restaurant? We work with our sanitation branch on that. They do food safety education classes with all of our restaurants. We're now including a little bit more information about rat lungworm disease now that it's becoming more and more prevalent and more heard of. So if you do find one, please give me a call. My number is listed in the phone book for food poisoning. And we do follow up with the restaurants with sanitation branch, and we make sure that the kitchen that they found one in is following proper washing procedures, etc. And we're actually in the process of updating our food safety guidelines specifically to address this. We hadn't had that before, so it's really nice to have now. Third question down is, what do I do if I accidentally ingest a slug? See your doctor. Let them know you ate one. Let them know that's what you suspect your symptoms are being caused by. I can't tell you if you call me that you got it because you ate one. I can't tell you vomit or do whatever might be crossing your mind at the time. See your doctor. That's number one. And we'll step in from there. Fourth question down I get a lot is, what are we doing about this problem? Number one, we're collaborating. We're working with the experts all across the state, across the globe right now, to figure out what we can do to minimize exposure to this illness in Hawaii. We have done education campaigns. We've done presentations to lay groups, to garden groups, to schools. Whoever asks for it, we will come out and do it for you. We've done radio interviews. Whatever we're asked to do, we're kind of trying to provide it if we can. Partnerships and collaboration are number one. That's what we're doing right now. Next question is, am I immune to this disease if I've had it before? A lot of people think if they've had it, they can't get it again. Yes, you can be reinfected. So don't, slack off if you think you've already had it, because you can be reinfected again. And the last thing is, how do I know and what should I do if I think I have it? Like I said, see your doctor. Let them know your exposure. Not all physicians will immediately assume that's what you have, because as you see, a lot of the symptoms are very general. So mention your exposure, mention your symptoms. That might be what you think you have. They will call for assistance if they need it. Okay, that's all I got. That's a fact sheet available on the CDC website. Right now, the Department of Health is revamping ours to include a specific site for angiostrongylolisis. So we'll have fact sheets, links to things like this, and other research articles. So stay tuned. That's my email address if you'd like me to email you information as it comes.
All right. I got involved in this because I'm a biologist, and I had a good friend who got the disease, and I had more good friends who got the disease, and it just kept building. And so I do have a background as an academic research biologist. But as in the community, I've just been kind of dealing with friends who've had it, basically. I put this subtitle, Fear and Loathing in Puna Makai, because, well, Puna Makai seems to be where most of the cases are, but I don't want you to be so fearful that you're paralyzed and won't eat local food, because local food is good for us, and that's what we need to be eating right now. But I want you to have enough fear, or maybe respect is a better word, that you will be really careful and avoid getting the disease. Frequency of the disease is just an unofficial count that I made myself in the community where I live, which is about 10 miles east of Pahoa, community of Kauai and Va'ava'a. In that community, 15% of the people who I know, which is 21 out of 137, have had the disease. It's a lot of people. That's a lot of the population. Of those, 14%, or 3 of them, have had it twice, which doesn't indicate that the ones who've had it have learned to avoid having it again. And then of the 15%, 43% of those still have symptoms years later. One of them I just talked to this morning. 15 years later, he still has weird feelings and pain in his legs. We need the medical community to recognize and treat this disease. The symptoms, from what I've been exposed to and these people that I've known, they're unmistakable. But despite this, over and over, rat lung sufferers have been turned away from medical facilities. Some of the 2 who went into comas were turned away 2 and 3 times before the time they went in when they were actually admitted. Several of those, so they nearly died as a result of it, in my opinion, as a result of that. The reluctant medical professionals are denying patients the early treatment that is likely to be key to minimizing nervous system damage, and that early treatment is the prednisone. And I don't know why it's so hard to get the prednisone. Prednisone is prescribed for skin infections. So, how to be safe while eating off of the land. I should say I eat entirely off of my land, and I think that one of the reasons that this disease is so prevalent in the area where I live is a lot of people eat mostly off the land. That's why people go there, people back to the landers. So this is what I do. I visually inspect all produce. And if you remember only one thing of what I say, remember those 4 words. Visually inspect all produce. And use your reading glasses if you use them for reading. You need to see those small slugs. And then throw away anything that has the disease-carrying organisms. And they were all mentioned already. The flatworm especially I want to emphasize because it wasn't talked about enough. But if you don't know what I'm talking about, there are these little things, you see them in the same kind of habitats as slugs or snails. Have this kind of big flared head that kind of moves around. They're real sticky and they break apart when you touch them. They can be all over everything. They can get on you when you're riding a bike. They hide in the folds of the lettuce, etc. So discard those items or trim away any contaminated portion if it's a piece of fruit from that has a hole in it and has a slug in it. Make sure you trim it away well. And then you might consider eating more cooked produce. Or just be prepared to spend a lot more time in food preparation. It is possible to safely eat local food, and even raw local food. You just have to have that careful attention. And I wanted to mention this because no one else, I didn't think anyone else would, and I haven't really heard it talked about. There's kind of an alternative manifestation of the disease, which I know a number of people who've had it in this way, where one arm, usually the dominant one, is affected, and shoulder and neck. And it's been diagnosed as a rotator cuff injury, but it was actually rat lung. These people actually tested positive for the disease. So, and one friend who's here today said it hit her like a bulldozer. Like, she never experienced anything like this before. It's not like the normal kind of injury you might get as this musculoskeletal injury. It's very dramatic.
It feels like somebody hit you with a baseball bat.
Speak from experience. Oh, and I just mentioned the test that showed positive for these people. It was mentioned there is an antibody test you can get. It's fairly reliable for indicating the disease, but the problem is you have to have had the disease for, I think, 2.5 weeks to build up the antibodies for that test to be effective. So that's too late for getting this effective prednisone treatment, which in the friends of mine who've had it was within the first few days. And those people who took it within the first few days, their symptoms were gone in a few days, and they did not have lasting symptoms like a lot of people who didn't get the treatment. So in summary, be careful and enjoy our fresh, local, healthy foods. And thank you all for coming. Thanks to all the speakers, Sue and Global Hope for organizing this. Okay, wow.
Mahalo nui loa. Thank you everyone for being here. It's great to see such a big crowd. I've probably spent the last 3 years trying to keep anyone else from having to go through what I've gone through. So I really appreciate this. My son was one of the people that did go into a coma. He was not expected to recover. We were given a 0% chance of recovery. The MRI showed worm cracks in his brain. The infectious disease specialist at Queens Medical Center in Honolulu said he may open his eyes again, but that would be it. I worked pretty hard. I moved into the hospital literally and worked with my son and Dr. Martel. I thank you for being here. It's great to see you again. I actually have a good story to tell on this one. So we ended up using quite a few, I lost the mic, alternative treatments, and these are actually backed by science, I've found now. A lot of my work comes from doctors who are working with people who are suffering from Parkinson's, Alzheimer's, and degenerative brain disease. So this is just a quick overview of Graham's condition in the hospital. He was in the hospital for 4 months, 2.5 months. He was in a coma. He had eosinophilic meningitis from the rat lungworm. His left eye turned completely inward as a result of damage to the nerve that controlled the muscle to that eye. He had the paralysis, so he was quadriplegic. In the hospital, he contacted secondary diseases, so he had MRSA in the blood, which is methicillin-resistant staphylococcus. He had something else called C. diff, Clostridium difficile, which affects the intestines and is highly, highly contagious, and is known to kill people, especially older people. He had pneumonia, which eventually perforated his left lung, and he had to be flown back to Queens for surgery. He had hydrocephalitis, which is extra water on the brain. They actually could see a reduction in the brain size. And he had elevated blood pressure and elevated heart rate. His resting heart rate was about 110 beats a minute. This boy was in really, really bad shape. After his hospital release, he still had a lot of damage, brain damage. He had short-term memory loss. He had severe ataxia, so very difficult to control the movements in his muscles. Everything was very jerky. He had some nerve damage to his extremities. He couldn't move his 2 fingers on his left hand. His balance was completely non-existent. He could not walk. We had to teach him how to do everything again. He had no core strength. He had double vision because of his eye. He still had difficulty with bladder and bowel movements. He was one of the people. He finally was admitted on the 3rd time that he was taken to the emergency room because he could not urinate, and that was why they finally admitted him. And he had an overall lack of energy and wellness, and this went on for 2.5 years. He finally turned the corner on the energy thing in May. It still is lacking. These are the supplements that we were approved to give to him in the hospital. We decided to just pull out all the stops. I come from a background of alternative medicine. I've used it quite a bit myself, including acupuncture. So a friend of ours who had rat lungworm down in the Puna area had the skin pain. He said, I took noni. I didn't have the skin pain afterwards. I recommend noni. So we were approved to give noni, spirulina, chlorella. Spirulina and chlorella are blue-green algae. Curcumin, which is turmeric, olena, it's known as here. And from a scientific study that a doctor at Queens found, there was a young man in a coma in China. He was given this Chinese medication, Zinniawan, and he came out of the coma in 4 months with some short-term memory loss. So we also added that. And after the hospital, and I should mention too that in the hospital he had a trach and a stomach tube. So he couldn't move, he couldn't do anything. And so I administered all of these through the stomach tube. After his release from the hospital, he was able, of course, to eat. He didn't have the trach or the stomach tube anymore. So we included fish oil, which is EPA, DHA. Later on, a friend offered to pay for IV vitamin therapy. She had had brain injury when she was quite a bit younger and had used this. So we did an IV vitamin therapy, which was alternating doses of phosphatidylcholine, glutathione, and then the next day it would be high doses of vitamin C and something called a Myers cocktail, so there's other vitamins mixed in with it. Later we added something called nerve support formula, and I actually found this doing some research for a friend who works for the UN in disaster relief, and he had a friend who had leprosy. So doing some internet research, I came up with this nerve support formula. We had numerous other things that we've added to this, but these are the ones I just wanted to mention. I also want to mention he was off all prescription medications by October 2009. So all nerve medications, all pain medications, all sleep medications, he was off of them. He did not have the skin pain, which he did have before he went into the coma. When he came out of the coma, there were some patches of it, but in his lower legs where he had it before, he had none. So this is what I found out now through some reading, and this is why I can see that these treatments were probably very helpful for him. So this is Dr. David Perlmutter and Alberto Vivaldo in a book called Power of Your Brain, The Neuroscience of Enlightenment. And they talk about the plant-based phytonutrients, which include the blue-green algae and turmeric, and how they activate these special pathways, this NRF2 pathway, which then turns on genes that express a lot of things to make the body start to produce anti-inflammatories and antioxidants. And it protects the mitochondria. And there's a great section in this book talking about mitochondria, because mitochondria provide all cellular energy. So basically, if you wanted to say something about, the life force, it really is mitochondria. So it's critical to protect these. So what was Graham dealing with? He was dealing with a huge amount of inflammation in the brain. This is his brain. He had demyelination, so the protective coating around the nerves was damaged. And so it's almost like if you have an electrical cord and the insulation is gone and you get shorting out and all that type of thing. It's kind of similar to that in a way. He had lesions in the brain. Those were all caused by the parasites. Because of the inflammation, he had free radical damage. And then he had a lot of toxins from the parasites itself and from a lot of dead cells, a lot of dead tissue. So these were the things that we knew we had to deal with. We had to deal with the inflammation. We had to somehow get rid of all of this dead necrotic tissue and these toxins. So here's just a little bit about inflammation. And for a lot of us looking at things like Alzheimer's, and I have many friends who have parents who are really suffering from this, but inflammation underpins the very process of brain degeneration. So in rat lungworm, you've got a huge amount of inflammation. That NRF2 pathway that produces the antioxidants and that produces the things that control inflammation, that pathway shuts down, and the brain is incapable of producing these things to protect it. So they need to be supplied from the outside. This talks a little bit about the damage to the mitochondria. Free radicals serve a purpose. They actually do something, they produce an effect that they refer to as apoptosis. And it's a process through which the cell tells itself to self-destruct. And that's a necessary process because we're constantly having to kind of rebuild the body and renew it. So it's really a very natural effect. But in a situation where you have damage and you have a buildup of free radicals, you start to get sort of a spiraling cycle of things getting worse and worse and worse. And so you can see there that excessive free radicals cause oxidative damage to tissues, proteins, fats, and even nuclear DNA. And the greater the damage from oxidation, the greater the degree of mental impairment. This is a little bit about the NRF2 pathway and how they're finding now that there are natural compounds that will activate that pathway and start the body to be producing these detoxifying enzymes, antioxidants, and things that will control inflammation. Also, they're finding that this substance that's naturally occurring in the body called glutathione is probably the most powerful brain antioxidant in human physiology. So glutathione has been found to be key to looking at brain health. And in fact, doctors can measure glutathione levels to find out how physically well you are. So, and then one more thing, this is all kind of neuroscience stuff. There's something called brain-derived neurotrophic factor, BDNF. And this protein plays a key role in creating new neurons. Now, looking at Graham, when I was in the hospital, I did a lot of reading. I read My Stroke of Insight, a book by a neuroscientist that talks about her stroke and what she learned from it. And also I read The Brain That Changes Itself, which talked about neuroplasticity and how you can have brain damage from a stroke or whatever, but the brain can find new ways to route that information. And so that's what they're using in stroke patients. Say your left arm is damaged from your stroke. Making yourself have to use it, putting your right hand behind it. They do all kinds of things to make that person have to use it. And what the brain does is it creates new pathways to make the body work. So this protein, they found turmeric and the omega fat DHA will increase the production of this protein. So let's look now at these things that we were giving Graham through the stomach tube. We were doing the blue-green algae, spirulina. Spirulina not only is really high in these omega-3s, but it's also a superfood. So Graham was being fed through the stomach tube something called Jevity, which was a can of, basically it was soy, corn, probably corn sweeteners, and vitamins mixed in. So we augmented his diet by giving him the spirulina. It's also so many other things, a building block for membranes surrounding brain cells, essential for brain function, modulates the expression for that BDNF protein. It's an anti-inflammatory, and it improves the function of the brain. Chlorella is another antioxidant, anti-inflammatory, wound healing. Graham had so many tubes sticking out of him, so helps with those kinds of things. Boosted the immune system, repaired nerve damage, and was great for treating degenerative brain disease. When we look at, too, that he had these multiple infections, I can see where these things really supported. He was on prednisone, so his immune system was suppressed. So you get all these infections. How did he survive? I think it was this. Coumarin, or turmeric, another phytonutrient, and activates that NRF2 pathway. Anti-inflammatory, antioxidant, antibiotic, antifungal. This one they're finding is very critical for degenerative brain disease. Fish oil, again, the EPA and DHA, those omega-3s, are really important in that NRF2 pathway, so that you're producing the things to battle the free radicals, to detox. Building block for membranes surrounding the brain cells, an important regulator of inflammation, and also modulates the production of that protein, BDNF, brain neurotrophic factor. Noni, we see it growing around here. This is an incredible plant. All these were supplements that I bought at the health food store, and this noni was freeze-dried. I bought very quality brands. So again, this was really helpful in helping his brain, helping with all of his other infections that he had, the skin condition, and it's interesting to note that noni is a pain reliever that's shown to be 75% as effective as morphine. This is a Chinese medicine that we gave to him. It's a consciousness-restoring medicine. We switched to something called Bu Now Wan later on. It was easier to get, and an acupuncturist Chinese doctor friend of ours said that it's a little pure of a formula. So again, it's great for treatment of neurosis, short-term memory loss, recovery of nerve function. Then vitamin therapy was done about 4 months after he got out of the hospital. And we continued that for 4 months, about 3 times a week. I feel that this really worked well, and I actually knew 2 other people at the same time who had had rat lungworm who were using this treatment. A young woman, about 28 years old, was diagnosed with rat lung. She went into the hospital. They would have admitted her. She didn't have insurance, and she said the hospital was really cold, and so she didn't want to stay. The nurse who administered this said she was close to a coma-type state. She spoke 3 languages. She couldn't understand what people were saying. She couldn't communicate. This is also very common in rat lungworm when it gets very bad. She's the only person I've seen who's gone that bad into rat lungworm who has completely recovered. So I think that there's something to this, and I don't think this would hurt anybody who has rat lungworm. And I think this could be something that could be looked at. So that, again, you're getting it through an IV, so it's bypassing the gut. And so you're really getting the full dose. So that's an important consideration in this. So the phosphatidylcholine and the glutathione, again, are super important antioxidants. And the glutathione also works in detox. That's the wrong way. Vitamin C is like an amazing antioxidant. And you have to look at the body is naturally producing free radicals. It just does that in metabolism. So it's a normal occurring thing. And your cells are creating thousands and thousands. They figure something like 10 to the 18th power free radicals are produced in your body every day. And they have to be counteracted one-on-one. So you can see the need to take a lot of antioxidants. Vitamin C is particularly effective. The nerve support formula, there's two forms of vitamin B, B1 and B2, and the forms at the very end are easier for them to cross over the blood-brain barrier than other forms of vitamin B1 and B12. So this has also been very effective. We saw, when Graham took this, we saw his balance starting to improve. When he did started the IV phosphatidylcholine, glutathione, and vitamin C therapy, his left eye started to straighten out. His therapists noticed that he could tell the difference between right and left better. So it was not just us that were noticing these things. This was my son, a picture taken of him last year. He's actually now taking some classes, 2 classes at the community college. He can ride his bike. He still has vision issues. He still has balance issues. He still has energy issues. He used to be a surfer. He used to be a skateboarder, very physical, could balance on a ball and walk, and it's not so graceful anymore, to say the least. But the economic costs of rat lungworm. One, you have the loss of productivity to the individual and possible lifelong disability. I know more than several people who are now completely disabled from this and probably will never be able to work again. The young woman that went into the coma with him, she's still on a ventilator, sits in a wheelchair, and guinea pigs they're pointing towards. The young man in Australia been in touch with his mother for over a year and a half. He's been in the hospital since April of 2010, still on the ventilator. They're trying to wean him off, and they're working on getting him in a standing frame. So this is an incredibly debilitating disease. Cost to family and friends. I was probably in the prime of my profession, shall we say, in my income earning years when this struck. I had to leave my profession and simply attend to my son, which I was so grateful that I could do, and it was probably because of that really, really intense care that I gave him that he has recovered so well. But it's put me on well below the poverty level income. So somebody's got to take care of people when they get this sick, and it costs them to do that. The cost of medication not covered by insurance. None of what we did was covered by insurance, none of it. And I still spend every month close to $200 or more on supplements for him. So yeah, it's expensive when these things are not, you have to pay for them yourself. So many of these things are beyond what anybody who gets this disease can actually afford to do. And the social costs, the cost to insurance companies, the cost to state and federal agencies, and collect Social Security income. Our goal is to get him back to a life where he can be productive again. He's going to be 27 years old next month. I would hate to see somebody this young not be able to have a part in society and have a productive life. So this is why I've worked again so hard to help him get well. And I don't know if he is here today or not. He might be in the other room. If he is, send a word over to have him come in. I'm really grateful that he's done so well with recovery. And like I said, I've been spending the last 3 years is not only taking care of him, but trying to do what I can to educate other people and get the word out. So thank you all so much.